Hello everyone. In last video we have seen that physical and chemical change with some examples, and we also discussed about 3 set of experiment that shows some chemical changes. So in this video we are going to deal with 2 topics. The first one is how to represent a chemical reaction in the form of an equation. The second one is how to balance a chemical equation. A chemical reaction is always accompanied by a chemical change. All the elements are in the pure form are really unstable. So in order to attain stability, they can react with other elements. This will be lead to a chemical reaction. Let's see what is a chemical equation. A chemical equation is a symbolic representation of chemical reaction by using symbols and formulas. Using symbols and formula, if we represent a chemical reaction, that we call a chemical equation. Burning of magnesium ribbon as an example, which we discussed in our previous video. Here, magnesium is react with oxygen to produce magnesium oxide. On the left hand side of this equation, magnesium and oxygen that are participating in this reaction and to produce magnesium oxide. So these substances that we call reactants. Then on right hand side of this equation, as a result of the reaction between magnesium and oxygen, magnesium oxide is produced that we call product. This reactant can be separated by product by using an arrow mark. This arrow mark point is always head towards the product side, which indicates that the reaction is always carried out from reactant to product direction. The same equation can be represented by using symbols. Magnesium can be represented using the symbol Mg and it reacts with oxygen. Oxygen can be represented by O2. Gives magnesium oxide is formed as a product. This magnesium oxide is represented by MgO. Here, the two equations represent a same chemical reaction. The first equation that we call word equation. And the second one is called symbol equation. So here the same chemical reaction can be represented by using word equation and symbol equation. Generally, we are using the symbol equation for representing an equation because it is convenient to represent. In the same manner, we can represent the reaction between lead nitrate and potassium iodide by using this symbol equation. That is, lead nitrate is react with potassium iodide gives lead iodide and potassium nitrate. In this equation, PbNO3 indicate lead nitrate, Ki is a symbol that represent potassium iodide, PbI2 that represent lead iodide and KNO3 which represent potassium nitrate. So these are the reactants and these are the products. Now let's look into balanced chemical equation. Here we can take the same example by the reaction of magnesium and oxygen. So here magnesium react with oxygen to produce magnesium oxide. Then just we count the number of atoms on either side of this equation. In the reactant side there is only one magnesium atom is there. But in the product side also there is only one magnesium atom. When we count the number of oxygen atom, in the reactant side there are 2 oxygen atom, but in product side there is only 1 oxygen atom. It means that the number of atoms on either side of these equations are not equal. So it is an example of unbalanced equation. This unbalanced equation is also known as another name that we call skeleton equation. Here, the unbalanced equation is not a proper way of representing an equation. So, we must be balance this equation. So, there is a question will be arise why we can balance this chemical equation. Just we can recall the concept of law of conservation of mass in 9th class. According to this law, matter can be neither created nor destroyed, which means mass before the reaction and after the reaction must be same. That is, mass of the reactant is equal to mass of products. Look at this equation. Magnesium has atomic mass of 12 gram. 1 oxygen contribute 16 gram. Here 2 oxygen is there. So the total 2 into 16, 32 gram. So all over in the reactant side, the total mass is equal to 44 gram. Similar way, on the right hand side of this equation, 1 magnesium contribute 12 gram and 1 oxygen contribute 16 gram. So here total 28 gram. So when we look this equation, here in the reactant side the total mass is 44 gram and on the product side the total mass is 28 gram, which means that this reaction is completely against the law of conservation of mass. So we must be balance this equation. Okay, now how we can solve this problem? Again we can write this equation one more time. Mg plus O2 gives MgO. Then we just count the number of atoms on either side of this equation. In reactant side only 1 magnesium is there and in product side also only 1 magnesium is there. In reactant side 2 oxygen atom is there, but in product side 1 oxygen atom is there. So in order to balancing this equation, the first preferences must be given the substance which containing more number of atom, which is either in the reactant side or in the product side. So here in this equation O2 which containing 2 atoms, that is more number of atoms. So we must balance the number of oxygen atom on each side. So here 2 oxygen is there, here only 1 oxygen is there. In order to balancing them, we just put the coefficient 2 in the right hand side. Okay, then again we can count the number of atoms. Here oxygen is 2, here also oxygen is 2. So the number of oxygen atom is balanced. Then in the case of magnesium, here only 1 magnesium is there, but in product side 2 magnesium is there. So balancing them, in the reactant side we put 2 as a coefficient. Okay, then we can check whether this equation is balanced or not. Okay, here 2 magnesium is there, here also 2 magnesium is there. Oxygen, here 2 is there, here also 2 is there. As a result, this represents a balanced chemical equation. Let's look into another example. Fe react with H2O gives Fe3O4 plus H2. This is an unbalanced equation. Then we can balance this equation by using this following step. The first step is that we put separate boxes on each substances in this equation. While you are balancing this equation, the substances inside the boxes could not be changed. Then the second step, we can count the number of atoms on either side of this equation. So first element iron, in the reactant side it is present as 1 and in product side it is 3. Then next hydrogen atom, the reactant side there are 2 hydrogen atom, the product side also there is 2 hydrogen atom. Then in the case of oxygen, the reactant side there is only 1 oxygen is there, but in the product side there are 4 oxygen atom is there. So then we move to the third step, that is the balancing step. In this third steps, the priority will be given to the compound which containing more number of atoms. So in this reaction, Fe3O4 is a compound that containing more number of atoms, and in this compound oxygen present as more. So first we can balance the number of oxygen atom on either side of this equation. Just count the number of oxygen atom on both sides of this equation. So from this column, there is only one oxygen atom is present at the reactant side and 4 oxygen atom is present at the product side. So in order to balance the number of oxygen atom here, we put 4 as a coefficient here. Now the number of oxygen atom on reactant side and product side become equals, that is 4. Then in the fourth step, we can balance the number of hydrogen atom on either side of this equation. So here on the reactant side there are 8 hydrogen atoms, but in product side there is only 2 hydrogen atom is there. So in order to balance this, we can put the coefficient 4 here. So this number of hydrogen atom is balanced in the reactant and product side. That is here total 8 hydrogen atom, here also 8 hydrogen atom. There is only one atom is remain to be balanced, that is iron atom. Then we can count the number of iron atoms on both sides of this equation. Here on the right hand side of this equation 3 iron atom is present, but in the left hand side only 1 iron atom is present. So in order to balancing them, so here we put the coefficient 3. Now we can check this equation is balanced or not. In the right hand side 3 iron atom is present, here also 3 iron atom is present. Then in the case of hydrogen, here 8 hydrogen atom is present on the reactant side, here also on the product side 8 hydrogen atom is present. Similarly, in the case of oxygen, 4 oxygen is present on the reactant side and here also 4 oxygen atom is present. So now this equation is balanced equation. Now let's balance this equation. The first one, hydrogen react with chlorine to produce hydrochloric acid. Here on the reactant side 2 hydrogen and also 2 chlorine is present. So in order to balance this equation, on the right hand side of this equation, so just to put the coefficient 2. So this equation is balanced. In the second equation, sulfur dioxide is react with oxygen to produce sulfur trioxide. So here we put the coefficient 2 here and here also we put the coefficient 2. So this equation is balanced. Then the third equation, the reaction of magnesium plus hydrochloric acid to produce magnesium chloride and hydrogen gas. In this equation, here only one magnesium atom is present on the reactant side, here also one magnesium atom, and but in the case of chlorine, here only one chlorine is present, here 2 chlorine are present. Here also in the same, in the case of hydrogen, only one hydrogen is present, 2 hydrogen is present. So in order to balance this equation, we put the coefficient 2 here. So this equation is balanced. In the last equation, the formation of ammonia, nitrogen is react with hydrogen to produce NH3. Here on the reactant side, 2 nitrogen atom is present and 2 hydrogen atom is also present. But in product side, only 1 nitrogen is present but 3 hydrogen is present. So in order to balance this equation, here we put the coefficient 3 and here we put the coefficient 2. So this equation is also to be balanced. I hope all of you understood this example. Let's meet in another video with more topics.